In this lecture we are going to continue with network analysis, and what we are going to cover is the concept of float and how float and slack are calculated. Now float and slack are interchangeable terms. In many places the term float is used. We also use the term slack. You will find that software which uses project management uses the terms interchangeably, and we will continue to use the word float through the rest of the lecture. Okay. I just mentioned our objective here is to understand the different types of float or slack, the definitions, the calculations behind this, and then the usage of float for project decisions. You may recall that we had covered network analysis in this manner, where we had inputs for the analysis which were relationships, durations and resources, and various outputs. So we have covered the set of outputs which are in this box, which is the early start, early finish, late start, late finish, the project duration, and we could, for the networks which we analyzed, we could actually find the critical path without any calculation or any specific identification. Today we will cover these other parameters which are outputs of network analysis, which is total float, free float, interfering float and independent float, and we will also find a formal way to define critical path based on floats. So this would be the exercise or the objective for today. Later on we will take resources. Resources are extremely important and they drive the whole project, and we will take how to take resources as input and do the allocation and various operations with resources, and that will be part of the resource lectures which come later in this class. Now what we want to do is start with these definitions. I do not expect you to understand the definitions as it is defined here. When we go through the examples you will be able to understand these definitions from the basic status, but what we will just go through the definition of these, which is, so there are 4 float terms as we discussed earlier. Total float is the maximum amount by which an activity can be delayed from early start without delaying the project. Okay. Free float is the maximum amount of by which an activity can be delayed without delaying the early start of any following activity. Now these two are fairly intuitive. Interfering float is the maximum amount by which an activity can be delayed without delaying the project but will cause delay to the early start of some following activity. We will take this up through an example. And independent float is the amount by which an activity can be delayed without delaying the project, and even if all the predecessors are at the late finish and all the successors are at the early start. Okay, so these are the 4 definitions, and let us get into some of the details, and the best way we want to do that is through an example. So this is an example we solved before. We have 4 activities A, B, C, D. We have the durations, we have the predecessor relationship given, and I am just going through the basic analysis to refresh your memory. So we did the forward pass, if you recall, we had the durations here, and we had the early times, the early start, the early finish, we went through, and then we found the project duration. And when we did the backward pass, we started with the project duration fixed, worked backward through the network, okay, calculated the late finish, okay, and the late start. You will recall the equations we had for it, and we come back to the initial node. So this was the analysis of the network, and we then put the various network parameters, okay, and we did the early start, the early finish, the late start, the late finish, and we went ahead and defined a critical activity because we could easily see that if there is any delay in activities A, C or D, the project duration will get delayed, and we could see that if there is a delay in B, there is no problem. So this is how we defined a critical activity in the last lecture. Now let us get more formal. So how many days can I delay B? 2 days. Okay, so I can delay B by 2 days, and it will not affect the project. So if we take the definitions we had, so we had, remember we had 4 terms. We had total float, which was the amount by which I can delay a activity without delaying the whole project. Okay, so what would be the total float of B? 2 days. Okay, so I can delay B without delaying the whole project by 2 days. Now what was free float? Any successive activity. So I can delay B again by 2 days without, it's a very simple example, without any successive activity, without. Okay, now what was interfering float? It was the maximum amount which activity can be delayed without delaying the project will cause delay to the early start of a following activity. So in this case, is there a delay for B? Any delay in B will affect the duration. Okay, so it's anyway going to, so interfering float what about independent? Okay, again I will go back to the definition, which I have to do it this way. Okay, if we look at the definition here, we have amount by which an activity can be delayed without delaying the project even if all predecessors are at late finish and successors at early start. So in this particular case, there is both the predecessor and the successor are critical, and it does not affect the way it would do what is required. So we would go into, what would it be? It should be 2. Okay, so we can now take, so the independent is also 2. Now you can see we put this into a bar chart here. Okay, and you can see that the bar for B is here. You can see the B, you can see it in blue. Okay, and you can see the 2 days of total float. Okay, there is 2 days of free float because I can move it here and it does not interfere with anything else, and it also happens to be independent float. Very simple example. Some of the more what I would say the complex issues of float are not coming out here. So let us take a slightly more complicated example. Okay, so we would, so this is the results which we have just discussed. Okay, so however we move it, this is the end we can move. So we have 2 days of total float, 2 days of free float, no interfering float, and 2 days of independent float. Let us take a little more, let's change the example now. Okay, I am just extending it, and we have this network now. We have A, I have just added another activity. Okay, and you can see the network, that is the analysis there. Okay, so we have 5, we have B of 2 days duration, D of 3 days, E is again 3, and C is 6. Quick analysis 5. I should have calculated B, but because I know the way it is going to go, that is why I have. Okay, so we did the forward pass, backward pass. What is the critical path? We can see that ACE. Okay, now we added D now. That is all we did compared to the earlier network. We have B and D. Okay, and we can see that certainly the critical activities have no total float or any float for that matter. Now let us see what kind of float B and D have. Okay, so you can see let us use total float first. Okay, does B or D have total float? How much? Is it 1 each? We will come back to that. What about free float? B 0, because the minute I start moving B, it will start changing the early start of D. So B has no free float. You can see D is moving into its successor is E, and there is a 1 day difference. So even if I delay D by 1 day, it's not going to affect anything in the network. Okay, so D has 1 day of free float. Okay, now let's just discuss of these two floats. So these are the most commonly used floats in project management, and they're let's spend a little more time discussing these two. When we say B has 1 day and D has 1 day of float, okay, so what we do on a project, so typically if a project has multiple activities, we will subcontract activities to various subcontractors. So here is a project, I have all of these subcontractors. I need now communicate information to them. I can say, tell subcontractor D, you only need to start on the 7th day, you need to come to my site on the 7th day, mobilize on the 7th day, and you need to be there for 3 days based on your decision, because B will be completing and handing over to you by 7. I need to tell subcontractor C that you need to come in on the 5th day because A will be completing by 5. So all this early start times gives me a way to break the project and give responsibility to the various participants. Now how will I use the float information? So can I tell, so basically if B has 1 day of float and D has 1 day, that means even if I changed, is it B has 1 day and D has 1 day? No. Okay, so that is a very important thing. So with B and D, this total float is actually shared. So there used to be a time when when CPM was new, B would look at his float and say, oh, I can take 3 days. It's okay if I finish on day 8. D will take a look at his basic information and say, oh, I've also got 1 day of float, might be I should take 4 days. What will happen? Yes, the whole project gets delayed, okay, by 1 day, because that float is shared. The minute one of them uses it, it goes off the network. Okay, so we have to be aware of shared float. What about free float? Is it shared or is it what does B has no free float and D has free float. So if you were allowing B or D to use that 1 day of float, who would you give it to? It depends, but if I give it to D, then there's less coordination between B and D required. If I give it to B, of course D loses that float, but it means that D has to now mobilize on 1 day later. Okay, so the way I use float matters. Now you have another way of the importance of float and criticality. So we have now certainly defined a critical path as critical activity as an activity which has no float, we know that. And if let's say the foreman who is doing activity B and the foreman who is doing activity C came and asked me for the same resource and I only had one of those resources, who would I give it to? C, because he is on critical path. Okay, so decision making like this becomes easier to justify when you have idea of what the float or slack is. Okay, now if we start looking at the remaining float, so we have interfering, and independent. Obviously A, C, E has nothing. What about B? So we can look at it on the bar chart here. So how much can I move B by? So here we have B on 6 and 7. Can I move it by? I can move it by 1 day, right? What happens when I move it by 1 day? I am interfering with the early start of D. How much can I interfere with the early start of D? By 1 day. Okay. So you can see in the bar diagram, it's that overlap, that cell, that 8th day will be an interfering day. D will, because of the predecessor relationship, D will be forced to start on the next day and move on. Okay, so that's that 1 day of interfering float. D has none. What about independent? Do any of these have independent float? D will have basically, right now you can see that D is influenced by the start of B. If I delay B, D gets delayed. That means it's not independent of B. There is no independent float. Okay, so both B and D have no independent float. Okay. Now if I wanted to, now are there any questions on this? Yeah.
Succeeding activity should not be delayed. That's what
No. It's the amount I interfere by. Okay, the amount that's why it's interfering. Okay, the amount I interfere into the successive succeeding activities. So here I can interfere by 1 day, not more. Okay, so if we go to the results from in the PowerPoint, this is the same as what we have got on the board. Now let's try to illustrate the concept of independent float. So I am actually changing the diagram a bit. What I am doing now is I am adding a relationship between C and D. Okay, I am just going to change this diagram. I am adding a relationship between C and D. I am changing the duration of D to 3. This is, I have 5, I have B is 2, C is 6, D is 3,
then it will become
11. Yes. Okay. So now this is this is where it is. So now obviously because of the relationship, this changes. Okay. So I'll rework my times. Okay, so 5 5, so now 5 to 6, this goes to 11. Okay, now I have here 11 going to, so here I have 7. Okay, let me take out all my, okay, so this goes to 14. Here I have 14 and 11, so I go 14 plus 3 goes to 17. 17, 14, 14, 11, actually this should go to 14,
11.
yeah, sorry, 11, 5, right. Okay. So this, the critical path now changes. Okay, where does it go through now? A, C, D and E. Okay, so because I changed the predecessor relationship here, now my critical path goes through this. Now let's see, it's the same example, slightly different relationships. And wait, I didn't finish this. Okay, so this goes back to 11 here. So now this goes to 11, 9. Okay, so again no floats on these because they are critical. And we now go back and see, take B, so B has, so we will have, certainly it's B which has the float. Okay, what are the kind of float B has? Total float, okay. What about free float? Interfering? It cannot, because if B starts interfering with D, what will happen? Project gets delayed. So in our definition, remember, you cannot delay the project. You have, how much can you interfere with any succeeding activity without delaying the project? So it has 0. What about independent float now? Can I delay A? I can't delay A. So B is independent of any movement of A. Now B can move without delaying D by 4. Okay, so there's space for B to move. So you can see it in the bar chart. There's space for B to move from in this whole region without influencing anything else. Nothing else gets influenced by that. Okay, so you have an independent of 4 days. Okay, so these, like we discussed the usage of total float and free float. Typically interfering float and independent float, you will find that a lot of software packages today don't even calculate it. They don't give you an option or they don't give you a field. So in practice the usage is not that much because people rely a lot on software. But it really gives you, especially independent float, gives you a certain idea of really the independence the activity has to the rest of the network, and how much of really float. So this float of B is, there's a lot that subcontractor can do with that 4 days without interfering with any other part of the network. So that kind of information also becomes quite relevant. Any questions? Okay, so just to wrap up this discussion on float, we discussed how the priority to critical activities versus non-critical activities can be assigned based on calculating float and and identifying critical. The second point is very important. We talk about criticality of a chain of activities. So here, what is it? What is the float for B? 4 days. Earlier, what was the float in the last network? 1. Okay, so 1 day of float. Are we saying the activity is not critical? What is the uncertainty in the project? You will find that the durations we are talking about here are deterministic, but if you had some kind of a probabilistic duration, that 1 day is very well within the range of change. So a lot of times you will not define critical path where total float is 0. You will say total float is in a range. Within 5 days of total float, it is critical, because the critical activity is not a binary decision, it's a subjective decision. It can be a range of total float. So that way criticality becomes important. So it's not critical but criticality. We talked about how knowledge of float can be used to balance subcontracted work. When should a person mobilize, when should he demobilize? All of these can be structured and subcontracted out properly. How much extra time could a person be given? Okay, later on we will be using float to balance resource loads. This is one of the most important applications of float, and we will be getting into that in great detail. Now the last question is also quite important, which is really, I mean, in an international context, this is why float has become very much part of the computation of CPM from a legal standpoint, because in this network it's not as illustrative because only B has float. In our earlier network, remember, B and D were sharing the float. Now can I give it, is there a contractual term on which who should I give the float to? Both had 1 day. Why would they want to use the float?
If there is any problem getting resources.
Right. So they are all under clauses to say if there is delay and they are doing something, that they might be liable to pay some damages or etc. They will want to use that 1 day, or they will want to increase the duration of the project of their sub activity, because increasing duration will be requiring them to mobilize less resources. So they might decide, I want to stretch because I will mobilize less resources, I don't have to pay for additional resources on that, and I can finish it in that time and be done. So this issue of how is float shared you know, it is still an issue of a lot of litigation in places. And today when you take a contract document in an international contract, there will be specific clauses on who the float belongs to, and always belongs to the owner today, and how the float should be apportioned in case of some need for requiring the float. So the subcontractors or the people doing each of these activities cannot assume that they have the float for themselves. So management for float has become a very key issue.